tasks. So it's a good thing. Luckily, we were lucky enough that when we made the curriculum for this lab, we had two parts, like some of the parts were being done in the lab itself, and the rest were mostly we were planning to do it on software, which was Matlab. So we are lucky that from pre-COVID we were able to do the major parts of our do the major parts of our labs over there. We are left with only one or two labs, but obviously those labs, the equipments were not working over there, so we can have that labs showed through YouTube video or something like that. I'll assign that. I'll do that accordingly. But from today onwards till almost the last part of our lab, we'll be only doing some examples, how to solve examples that are in your book through MATLAB, right? It is a good way of the MATLAB tool will help you guys to solve complex problems easily, instead of doing it through your like normally through the genuine like hands-on, like that might contains lots of calculation, and it might take lots of time. The MATLAB will give you guys a leeway of doing it quite accurately and precisely. One thing which I noticed in the last while teaching in section A was that when I asked the question from the students that are you guys have you done are you following the book Chapman, right? So they said that yes, we are doing it, but unfortunately they said that we are not reading the book because we are only confined to slides. That is the worst thing that you guys can do. uh, uh, Adapt the habit of reading or studying from book instead of slides. Slides would confine your knowledge, while reading TechnoSpark Go, ask that guy to come up with his or her name. I'm not gonna allow a person with such names into my class, right? So what I would suggest you guys, get this habit. And the best part is you guys are new to this system, so because normally we are quite adapted to this skill of learning from books. When we are in FAC or A levels or O levels or matric, we normally do it through books. We normally study books and we read the books, and we like we get the concepts from books. Unfortunately, when we come to universities, I don't know what happens to us, that we start only studying slides or home or class tasks or classwork. So obviously it is good for you to get marks, but it is not good for you guys to it will not broaden your knowledge. And ultimately, if you want to improve your knowledge, like if you want to do your masters or if you want to do your PhDs, or if you want to compete with the best, what happens in that case is that you have to have the knowledge about that topic from different aspects, right? The slides would give you only one type of aspect about that topic, but the book would give you knowledge, and different books would give you knowledge on that same topic through different perspective, right? So it would obviously broaden your knowledge and broaden or vasten your skills or vasten your knowledge about that particular topic, right? So I would always recommend to read the book, learn from the book. It is obviously useful for getting GPS, but with this skill, it will be easy for you guys to do your post graduations, because ultimately when you are doing your post grad, so uh, you are trained by the slides so much that you are unable to read from books, read from different sources like journal papers, articles. And what it does, it becomes extremely difficult for us to do our postgrad or PhDs and post PhD, right? So just have this habit of studying books. So I was surprised and literally shocked that literally the first example of the Chapman book, you haven't done it. So uh, I was thinking that obviously I won't be going through the theoretical aspect because you would have covered it and you would have covered it in your theory. So I'll be just going quickly through the how to do it through your uh, through the Matlab, right? So, but again, as I came to know from the section A, so I that you don't know how to do it. So let's stick to that your hands-on experience, like hands-on doing of this problem as well. So this question is basically example 1-1, which is basically about a ferromagnetic core, or a ferromagnetic core is nothing but a core which is made up of a material, specific material called as iron or ferrite. Why it is done? It is to done to improve the or increase the inductance of that coil uh, when you increase the magnetic field, right? So obviously this is the way, like if you want to have more inductance in a coil, and when you increase the magnetic field, you need to normally people, and it is a very most one of the most common type of core which is called as ferromagnetic core, right? So what happened, this is the basic concept of it. Let's read out this example, like what it is saying. This is a ferromagnetic core which is shown in figure 17a, and another one is the resulting magnetic circuit. This is the another example, this is another figure. So we have two figures, right? So it is showing that the example one, it is showing that we have an example of a ferromagnetic core in which three sides have a uniform width, and the three sides have a uniform width of 15 centimeter. Only one width is 10 centimeter, remaining are 15. And the width of there are two regions, region 1, which is basically denoted by L1, and the remaining region is called as region 2, right? So the region 1 has a width of 10 centimeter and region 2 has a width of 15 centimeter, right? So and the remaining regions, the remaining region, like remaining sites have a width of 15. So the remaining region is obviously region 2, so it is 15, right? So the depth of the core is 10 centimeter as shown here. There is a 200 turn, the number of the turns around the coil is, this is 200 turns. And the permeability, basically what is what what is basically permeability, relative permeability, which is this mu r. It is basically a ratio of a permeability of a specific medium, which is in this case ferromagnetic, and a fer and to the which basically to the permeability of a free space or a magnetic circuit, which is a constant. Its value is 4 pi by 10 into 10 raised to the power minus 7, right? So you have the value of relative permeability, and you have a constant value of uh, called as permeability constant, or you call it as mu naught, or you call it as uh, permeability uh, for a constant value of for a magnetic circuit, right? uh, uh, it is like mu naught is a permeability of free space or a magnetic constant, right? Its value is 4 pi into 10 minus 7, right? So and the question is that find the flux basically means that the amount of magnetic field passing through that particular surface, right? So for finding a magnetic flux, you normally have this formula, that is magnetomotive force and divided by the total reluctance, right? I'll explain the magnetomotive force, which you know, I'm sure. but I'll just briefly explain it in the later part of the lecture, right? So for in order to find the reluctance, basically it is nothing but it is the length of the region divided by the permeability constant, or permeability. What is permeability in this case, which is basically mu is the measure of the resistance. Basically it is the measure of the resistance of a material against the formation of the magnetic field. Means कोई material जो resistance provide करता है against the magnetic field, उसको कहते हैं हम permeability. This mu is equal to nothing but mu r, which is relative permeability, into the mu naught, which is relative permeability of free space or magnetic constant, having the value 4 pi 10 raised to power minus 7. So the length of the region 1, which is this, is region 1. This is the entire length, and the region length L1 is basically nothing but 30 plus 7.5 and 7.5. So it becomes 45 centimeter or 0.45 meter. And the same goes with mu is 200, mu naught is this value, and area is, as I said, that the width of it is 10 centimeter into 10. 10 is the depth, so 100 centimeters square or 0.01 meter. The same now for R2, for region 2, which is basically the remaining. So it is nothing but, let's say this one, L2 is 30 plus 5 plus 7.5. It becomes equal to 42.5 into 2. It becomes 85 plus 45. It becomes equal to 130 centimeter. And by converting it, it becomes 1.3 meter. And as the width of the remaining sides are 15, into depth is 10, so 150 centimeters square. So the reluctance comes out to be, total reluctance R2 becomes equal to 27,600, right? So the total reluctance is nothing but the sum of it. When the, if you look at the magnetic circuit, this is nothing but it is equal to the sum of both. So R equivalent is R1 plus R2, right? So R1 and R2 sums up out, the sum comes out to be 41,900 ampere into tons divided by Web, right? So now finding for a magnetomotive force, as I said earlier, magnetomotive force is nothing but a it is just like a Ohm's law for magnetic circuit, right? Do you remember Ohm's law? V is equal to IR. So the same way is it is a magnetomotive force, which is equal to F is equal to magnetic flux into reluctance, or it is also called, the formula for it is N number of turns into the current in the ampere, right? Current in terms of ampere or I, basically, right? Let me, okay. So from here we find out the magnetomotive force, which is N, which is 201. So 200 ampere into turns is the answer. So for the flux, as I told you before, the flux formula is magnetomotive force divided by the total reluctance. So by finding that value, we'll be able to find the magnetic flux of that core, right? So this is how you do it through, like, you might have done it in your papers as well. You might have the reluctance given to you, and you might have there are different, you might have magnetomotive force given to you, and your question would have come as that what is the total flux for that core. So which is basically, it is easy, you can do that through your simple calculations and through your it's a hands-on example. You do it on piece of a paper and just through your pen. Let's say if we want to do this, the same thing on a Matlab, because it is just for you guys, it is just uh, the purpose of doing it through Matlab is that the Matlab is a platform that you, through that you can solve very much complex problems, right? As I showed you in the lectures prior to your midterm exams that we can plot the graphs. So imagine if you have graphs in an equation, and you have to obtain it through equations, and you have to solve the equation and then plot the graphs. So what the best part in Matlab is that it does it quite easily for you, right? So let's say I'm doing it through Matlab. Ji, more chat. What is the question? Ji? Tell again about the relative. अच्छा जी, relative permeability. अच्छा, relative permeability बेटा ये होता है, relative permeability is nothing but it is एक रेशो है between एक एक चीज की एक स्पेसिफिक, नॉर्मली आपको बताया होता है कि स्पेसिफिक मीडियम, एक जिस तरह यहाँ पे इन्होंने लाइक नॉर्मली ये आपको एक स्पेसिफिक मटेरियल की परमेबिलिटी होती है, तो उसकी और एक फ्री स्पेस मींस मैग्नेटिक, एक मैग्नेटिक कांस्टेंट एक वैल्यू है दिस वन, इसकी जिस यानी फॉर एग्जांपल म्यू आर इज नथिंग बट म्यू म्यू डिवाइडेड बाय म्यू नॉट. व्हाट इज म्यू? म्यू इज नथिंग. यहाँ पे मैं कुछ कहीं पे लिख सकता हूँ कुछ के नहीं. आई थिंक आई कैन राइट समवेयर. अच्छा, मैं पेंट पे खोल देता हूँ एक मिनट. अच्छा बेटा, रिलेटिव परमेबिलिटी मैं यहाँ पे कैसे लिखूंगा? एनीवेज ये relative permeability जो कि basically this one mu r equal to mu it is mu divided by mu naught, या फिर mu equal to mu r और mu naught बराबर के बराबर है. ठीक है, तो mu क्या चीज है? mu is nothing but it is basically permeability of a material. permeability क्या चीज है? permeability है, permeability means permit से ये निकला है कि measure of the resistance, ये जितना resistance करती है एक मटेरियल की तरफ से, एक मटेरियल की तरफ से एक रेजिस्टेंस प्रोवाइड करती है किस चीज के मैग्नेटिक फील्ड अगेंस्ट द फॉर्मेशन ऑफ अ मैग्नेटिक फील्ड. ये वो चीज